to create as many validations as possible. We have a couple more validations in the absurd backup configuration method, and these validations return or include the error codes specified over here in case of failure. But we'll look into that in more detail later on. For now, let's proceed to the web application itself. Now, the web application hosts both the REST API and the front end on the same domain, which is the ASP.NET host. We have the REST API controllers inside the controller folder itself. So we have the backup configuration controller, the client controller, and the user controllers. The backup, we are also using custom authorization and authentication. So a client can authenticate using the user API's authenticate method, in which case he's going to receive a token, and this is completely stateless. In this implementation, I'm using simple string-based token, but in the real world, we would use something more secure, like the JWT or the JSON Web Token, and the client will then include that token with every request it sends to the server. The server will then authorize the client based on the information provided in the token. So, for example, the authenticate method is going to return the token to the client, which is adulterated using a salt, so that it could be prevented against the rainbow table attack. Essentially, the hacker or any hacker trying to sniff the password is not able to look that up in the rainbow table because it's already adulterated using a salt. It's a standard authentication security mechanism with REST-based or web applications nowadays. And it's also stateless. That's the good part about it. Then we have a custom authorization filter, which parses the incoming token from the client request and processes it based on whatever role-based authorization is implemented in the application to allow or deny access to the endpoint, which is decorated using the authorization filter or the authorization attribute. One example of the usage of the authorization attribute can be seen here. For example, this. And during the demo of the application, you'll also see that the client or the user will not be able to use specific features meant or that require administrator privileges. So the REST API communicates to the clients using standard DTOs or data transfer objects, so it does not use the application models or entities directly in order to communicate to the client. Instead, it uses custom DTOs which encapsulate the information or the data being transferred to and fro from the clients to the API. Next, I have implemented dependency injection in the REST API application. So I'm using Unity as the IOC container to perform the dependency injection, and the registration for all the interfaces happen in the Unity config that we have here. So for the unit of work, and which is essentially the context, I'm using the per-resolved lifetime manager, which means every request that is resolved bears the same instance of the context. So the context does not change within a request, but it changes or renews or reinstantiates across requests. Alright, so the next is the UI layer itself, which is built using the AngularJS JavaScript framework, and it's included in the scripts folder within the ASP.NET project itself. Now we have a specific folder called the TheBackupApp, which contains all the script files responsible for running the UI. And let's have a quick look inside that. So we are following the standard MVC model of the Angular framework for running the front end. In the controller, we have a couple of controllers, starting the activities controller, backup config, backup configs controller, which is responsible for the list view. The login controller, redirection controller is for a specific purpose for handling the client-side routing or redirection, sorry, based on the Angular routing. Next are directives, which are the Angular directive. I'm just using one here to display the login bar at the top of the page. We'll see that during the demo. Next are filters, just one basic filter to format the date to a specific format on the UI. We have used this filter inside a template here. So we have the services. So we have two basic services for communication to the REST API for the front end. And the next one is the templates folder, which contains all the templates that are going to be rendered. This is the HTML pages. And next we have the tests folder. So for demonstration purposes only, I've included Jasmine tests specifically designed to be run for Angular apps by using the Karma test runner. And both Jasmine and Karma are installed in the scripts folder using npm. And so we will run the test before we start the demonstration of the whole application to see how the tests, how the unit tests work. And just to explain what this single unit test that I've included here does is it just verifies that the backup config service contains or has a method defined, or the config service itself is defined, or it exists. So that's just a basic unit test, just to demonstrate how unit tests work for an Angular application, and we'll run that shortly. So next, so the whole application also contains MS tests, and also for demonstration purposes I've included OneUnit Test, which is also configured to run automatically post every build. So, and this test just verifies if the backup configuration API can save and retrieve a new backup configuration. And we'll run these tests before we start the actual demo, just to display how these work. And real quick, let me also point to the MS test command, which is configured to be executed post every successful build. We have a build event, and here's the MS test command that runs the solution test on successful build. Alrighty. So now is the time that we go ahead and start building the solution and eventually proceed towards our much awaited demo. Let me keep my fingers crossed. So let me build the solution right now. Alright, so it's complaining about something. Says the MS test is not able to find the test DLL, it seems. So this is nothing to worry about. Maybe the test DLL did not compile properly because this is the first run. Let's compile it one more time, so it should be able to find the test DLL. Let's compile it one more time here. Alrighty, so it compiled successfully. So that was the issue. The test DLL did not generate in time for it to find it. So we see that the solution test has actually run successfully, and it asserts that it can save, the backup configuration API can save and retrieve a new backup configuration, and this is for demonstration purposes only. Alrighty. In the meantime, before we execute this, application, the web application. Yeah, I must quickly also mention that the database used is the local SQL Server database of Visual Studio, and it populates the database and seeds the user data on the first run of the application, so we do not have to manually go ahead and configure the database or put in the data inside it. We're just good running the application directly, and it will take care of us for now with this development environment. And of course, because we're using the repository pattern, it's completely abstracted to and provides the flexibility to use any database for that matter. However, before proceeding, let me also go ahead and quickly open the client agent solution, which is the other part of our application that is going to be installed on the Windows client machines, from which we'll be running the backups to another location. So let me open that real quick. Alright, cool. And let me quickly also explain the architecture or the project. So we have three main services. One is the backup service, responsible for running the backup. Communication service is responsible for communicating to the REST API. Scheduler service is responsible for configuring the task scheduler. So in this application, I'm leveraging the Windows task scheduler for running the scheduled tasks, or the scheduled backups for the matter. And that task scheduler is going to invoke this utility itself, which is going to be installed on every single client that we would like to schedule the backups on. And yeah, utils contains other utility classes. And without any further ado, let me just go ahead and try to build this one so we can use. Alright, that built successfully. Let me just copy this path here. So we'll be using this application to install and run our client agent. Minimize this. Open a command prompt. Paste this here. And also keep it aside for a minute. Before proceeding here, let me go back and run the web application, keeping our fingers crossed. Oops, alrighty. So this is not a new error. It's a known issue. It happens sometimes when you manually delete the SQL DB, which I did before. So all I need to do is close this real quick, go back here, and do a little magic trick suggested by Microsoft, which I was able to get my hands on Stack Overflow. All I need to do is stop the local DB instance and then delete it. And that's pretty much it. So that should be able to do the trick and get us rid of that error. Let me try to run the application one more time, and hopefully it will work in this instance. So because this is the first run, it's taken a little while because it needs to perform all the configuration for the database, run the configuration, seed the database. So there we go. This is the home page of our backup application management console. And because we do not have any configurations as of now, that is why we don't have any listed here. These are search boxes, so you can search. And so we require the administrative login in order to be able to see the administrative functions in the application, as I discussed before. For that, I will have to go ahead and sign in as the administrator. So the moment I sign in, there I go. I'm able to now view and use the Create a New Backup Config button.